I'm going to pick up right where we stopped. You may notice that version number of fasmg keeps changing from day to day. Well, what we are doing here is also about this, that I can still develop a 32-bit code of fasmg, and the tricks we make here to make it run in long mode do not care that much. They are just applied to a new code, as long as I follow general guidelines that I mentioned that I follow. For example, that I do not modify stack pointer directly, only do push pop in instructions. So where the previous session ended was that we were testing and we had this segmentation fault. You may have noticed that I used FDBG already to take a look at this. A few days ago I have shown how to use FDBG in Windows. Well, FDBG also has a Linux version. Again, FDBG is written by a member of fasm message board, nickname Ferrino. So it respects fasm syntax, and it's really nice handy little debugger, 64-bit debugger. Okay, let's run this program. We have a segmentation fault on this instruction. Such memory access caused the fault. This is the value of RSI register. So RSI pointer got broken. I did a little investigation yesterday and I found out that this malloc function does not always restore ESI register. This is how it restores it. It restores it from a register R13. It stores it here. But this is not the only way that we can exit this function. And here it was forgotten to restore ESI. And this is what was causing this problem. I have already prepared a fixed version. In fact, this fixes two bugs here. Not only it restores variables, but also adjusts the size returned. It was also wrong. Oh, by the way, this reassembly is much faster when I'm not streaming. Apparently streaming is burdening my machine enough so that fasmg runs slower. No segmentation fault this time. But also it did not display anything. Well, this is because I forgot to display. This is a regular path. This other path is only taken when we cannot resolve code. After we reach maximum number of passes in this loop, if the code has not been resolved, we just show display and show error that code cannot be generated. This time we have some display. Well, I think it looks good. This means that this instruction has been assembled. No, this is not hex, this is decimal. Well, let's change it to just a name of file and switch it here. Instead of assembling commands from memory, we are going to assemble file. Oh, another problem. Interesting. And what's when we create this file? Okay, it works. We have some problem in error handling. Well, we can try something more interesting, perhaps. Yeah, assembly works just fine. Only something wrong happens after it is finished. Probably in the shutdown, maybe? Assembly shutdown calls M3 a lot. So perhaps there is some problem in M3. Is this in... Oh, I see. Yeah, I should have perhaps documented this. That M30 is something that might possibly happen. Yeah, I did not document it, but you can see that my function handles this. I just forgot to document it. Back in documentation, perhaps. Yeah, in fact, 0 and -1 should be handled automatically as invalid values. No error now. And no error when file is missing. So this was the bug, okay. Okay, so assembly works. We should now add some console interface and then we have fasmg simply working, I think. Oh, well, I should fix this error. Error in documentation, that is. Oh, and as we are here, I think this push here and then pop is not really necessary, because either we would document this here, that these are preserved registers, or when we not document this, then we do not need to preserve them really. This is a hard rule in fasmg core, that when register is not set to be preserved in this documentation of function, then you should never rely on it being preserved. Yeah, I know about ABI, but this is not a Linux ABI or any other ABI. This is fasmg's calling convention, where everything about each function needs to be documented right when the function is defined. So unless we add these registers to this documentation here that are preserved, we are free to destroy them. So I'm going to destroy them. Okay, next one is realloc. Okay, here the same. Right, and it should work, I think. Well, there are many things that I would need to reformat here to my own preferences. I would most likely change this to uppercase constants, because this is like the convention I used in fasmg. Also, we are not error checking those values. Well, we can error check them easily. Just do it like that. Must be power of 2. For example, like this. Let's do a sanity check. Oh great, I have broken something. Yeah, the initialized variables are not a big deal for me. Yes, they can stay like this. It's okay. But alright, I think I have broken something when I removed the pushes. Where do we have something like that? Oh, probably this one. But why? Why did it break it? Let's scroll back in time. Yeah, okay, I see. Realloc calls malloc. Let's put this back here. Yeah, so if realloc needs these registers to be preserved, then either we need to document that they are preserved by malloc, because if this is not documented, then realloc is not allowed to call malloc this way. Since malloc is not documented to preserve these registers, then realloc is not allowed to assume that they are preserved. But it can preserve them itself. I'm using this opportunity to show general approach that I used in case of fasmg architecture. That when you call a function, you need to make sure that you know what this function can preserve for you and not assume anything other. there is no common ABI for these functions. Okay. It works now. And let's go back to getting a console interface. We can perhaps reuse some of the Linux. Get arguments is the most important. Let's copy it all and just convert to a long mode version. Okay, this function remains to be implemented. This should be okay. This is a syscall that we need to change to a 64-bit syscall. Let's take a look at some reference. This is 96. 2 arguments. Time zone is null. Ah, 96. Yes, you're right. This should be EDI. Thank you for catching my mistake. Alright, we have another one here. And this is perhaps going to look a bit different. I assume this structure uses 64-bit fields, am I right? Then we need to simply convert this. To use 64-bit registers. Yeah, are you sure they always fit in 32 bits? If yes, then we can simply add overrides and not worry about it. Oh, you mean right now they fit? Yeah. 2038 is far from now, but this does not cost us much to just make it future-proof. Well, a few dozens of rex prefixes, probably. Oh, okay. This function takes input in 2 registers. Therefore, we need to split it. This should all work without changes. This also. This we need to change to the right syscall. Assembly failed, we usually give a code to. Alright, not that bad. Now we need to convert the get arguments. Yeah, this is... we use the pointers that may be 64-bit here. Yeah, I have the variables already set up. It was here earlier. I have converted this already. Well, to be honest, I don't think we are going to have more than 4 billion arguments. So let's assume that ECX is enough here. But the pointers we need to use as 64 bits. Oh, this is a problem then. We need to handle this in a moment. For now, I'm just changing size of pointer registers and ruler. Oh, I see I can make a little digression again about I said last time that this kind of instruction, when it is interpreted in long mode, the same binary code that would be this instruction in 32-bit mode becomes this one, because addressing switches to 64-bit, but operands stay as they were. And I'm going to try this trick later to produce exactly the same code and just reinterpret 32-bit addressing as 64-bit. But currently we just assemble the instructions in fasmg as they are. So this generates a 6-7 prefix and uses 32-bit addressing. However, when we use instruction like loadsb or mavsb, and I use them a lot in fasmg sources, mainly because they produce so short code, then this instruction in long mode is going to use RSI by default. But this is what I had already been saying, that since we know that when the pointer in ESI or EDI was set up, the upper half of RSI or RDI was cleared, then this does not really matter. It uses the same addresses, just with upper half cleared. This is a really nice feature of long mode encodings. But in fasm1 sources, let's look for some maps. You may notice that in fasm1 I do not use short forms of this instruction. I always use full forms with operands specified. Then assembler when assembles in other mode, applies appropriate prefixes here to ensure that this size of registers is used. And finally, this dates back to times when fasm1 was still running either in 16-bit mode in DOS, 16-bit mode both with 32-bit addresses, or in 32-bit mode in Windows and Linux. So the source had to be written this way so that when this was assembled in 16-bit mode, that the right prefix would be put here to use EDI and not just DI. We've come a long way, and now it's not 16-bit versus 32-bit, now we have 32-bit and 64-bit mode, and trying to reuse the same code. But in fasmg I no longer use this approach to use long form of the instruction. So we would have to handle this with macro. If we really wanted to ensure that this uses 32-bit versions, then we would need to make a macro for this. And so on. Alright, that was a small digression. Let's go back here. So here we have lots B instruction that is going to operate on RSI, so it should work out. Wait. Initial commands. This is our memory block, so this is going to have 32-bit address. So okay, we can leave this as is. Yeah, the value of argc, argv, the pointers given here may be, oh, this should be 8. Another thing I forgot to correct here everywhere. Okay, this should be mostly ready. We have a big problem here. Because originally we just stored pointers to source and output path. But now if this resides in upper memory area, then assembler cannot access this through this pointer. So we need to move them. In the beginning we can just hope that for initial tests we are going to have this accessible in low 4 GB. Yeah, we need to copy it somewhere, so we need to make some buffer and... Well, for initial commands this is already done, so we need to make something similar. No, simpler, because initial commands it's a growing buffer. This is no longer needed, but there is a couple of other data that we need to copy. Let's see if this assembles at all. I forgot to copy something. Well, yeah, it assembled. Let's run it and see what happens. Usage information is displayed correctly. And this does not work. Well, perhaps this is in a high memory after all. So we need to move this. No, this is not on the stack. At least this does not have to be on the stack. What is on the stack is pointer to the table, but the pointers within the table can point anywhere. Also, what we did here, we truncated the pointer. We only took the lower half, so we do not even know how the whole address looked like. Okay, let's do what you say and make something like string duplication function. This is an ESI, and we need it to preserve RBX and RCX. Oh, like this. Okay, we need to preserve this, and also this, so we cannot return in the same register. Let's copy this. Now let's malloc. You can see how my conventions work out. Just by convention, size or count is ECX for me. So now I can just call a malloc directly, I do not have to set up arguments. However, I need to preserve this size. I can preserve in EBX register because a malloc should preserve this register for me. This is a very plain exception handling in fasmg. There are few so-called fatal errors that just display message and exit program immediately. So I can just jump from anywhere in code, not worrying about restoring stack or anything like that. Yeah, we could do it like this, but well, a malloc was assumed to be a bit like an external function. Alright, what am I doing here? I need to preserve entire RSI also. You know what, for simplicity, let's just small code and clear. Let's just preserve the registers this way. Just like that, I think. Yay, it works! We have a working fasmg. You know what? Let's go big. it has just reassembled itself under 64-bit Linux. As a 64-bit ELF executable, I mean. And in fact, the time is exactly the same, you see? There is still one more thing we can try. I wanted to try getting rid of 6-7 prefixes. Then executable would be much smaller. But this only works, as I said last time, this only is going to work when we do not use negative offsets in registers. Yeah, the core is the same, but I mean, the fact that malloc is not much optimized does not really matter. I said it last time, I think, that bottlenecks in fasmg are elsewhere, and malloc does not really matter if it's a bit slower. Yeah, this is funny, but let's try it and see if it really works. Perhaps I am using a negative offset somewhere and I simply don't remember. But I'm pretty sure I do not. Yeah, executable is a bit smaller. Not much. So perhaps this is not a hill to die on. Let's try if it works at all. Okay. Well, it does work. Funnily, a bit slower this time. But this one was also a bit slower. So, what do you say? Which variant should I use? This one has a bit smaller code, but not by much. And the other one is more foolproof, one would say. Yeah, of course, you're right that more testing would be required. The difference in size is not that much, though. Only about 2 kilobytes. Really a small difference. The larger one is more safe because it preserves more instructions in the original form. So I would say the larger one is less modified in this sense. However, the smaller one is more similar on binary level. So one is more similar on the source code level, and the other one is more similar on binary level. I would myself say that apparently these 6-7 prefixes do not impact performance for us, not visibly. So I would stay with 6-7 prefixes just to be on safe side. Now, malloc, as we can see, it does not really matter that it's not finished. But I think this is a place that requires some action anyway. I think we would need to reuse this code. Please correct me if I'm wrong. Because when we need to grow a block A, and let's say the next one is 3, and we need to grow A just a little, we could reuse code from malloc telling it to allocate this memory from this block. It would then split it into 2 blocks like this, and then we would merge the 2 blocks afterwards. For this reason, I would like to make this code shareable between malloc and realloc, either as subroutine, or realloc could set up everything so that it could jump here and no, not jump. Call this one. Yes, I'm going to work a bit on this, change it to my visual standards also. Anyway, 64-bit version is working. So I think we can leave it at this point. Oh, one more thing about this malloc. I'm also thinking about adapting this code to 32-bit mode, because regular Linux version currently requires some dynamic linking to get memory allocation. If I reused this also for 32-bit variant, then I could make regular fasmg for 32-bit Linux not require dynamic linking. This would also be nice, just syscalls. Yeah, I would need to, in system, ENC, make a routine for perhaps this type of routine and use it from malloc. Also, these registers I would probably make definitions like etc. So yeah, I believe this is easy to do. We can try it tomorrow, as long as we do not have anything more interesting to do tomorrow. Okay, thank you for watching, and that's all for today.